Hello everyone, welcome to Linear Model with me Sarini Abdullah. For this session, we will learn about model building, particularly when we do modeling, I mean that multiple linear regression using quantitative variables. We also need to consider what kind of treatment to be given to the predictors of qualitative variables. And we will see specifically if we only have one predictor in the model, and later on we will generalize if we have two or more predictors in the model. So just a quick recall on the form of the model. We can have it in the form of matrix multiplication in here, where we have matrix y equals x beta plus epsilon, where the y is the matrix of a response variable, x is the matrix of predictor variables, with the first column is a factor of ones that should be associated with the intercept beta naught. This is x1 associated with beta 1 all the way. This is the pth predictor of xp associated with beta p. And here, the matrix of error measures the discrepancies between the actual value and later on the value, estimated value given by the model. Okay, we can also write our model in the form of equation like here when we are referring to each of the observations. So yi equals beta naught plus beta 1 x1 I all the way to beta p x I plus the epsilon. Or in short, sometimes we can just write our model not taking the whole part of this one, but just taking the deterministic part of this one. Okay, and this is just the expected value of the yi. So we can also write our model in terms of just the deterministic part given by the last expression here. So the concern of the model building is that about the predictors that are put in this model. Okay, so in that case, we want to be able to include those predictors in its correct, appropriate functional form that should resemble a good fit or correct relationship between those variables and the response variables yi. In order to be able to do that, we should be able to give a correct treatment. What I mean by treatment is that determine what kind of transformation, what kind of functional forms to be included in the model. And to be able to do that, we should, be able to differentiate between the quantitative predictors or numerical predictors, the qualitative predictors or the categorical predictors, and what if in the model we have a mixture of quantitative and qualitative predictors, and also later on we need to consider whether we really need to include higher order terms in our model. So these are the main concern or the main aspects that we need to focus on when we do our modeling. So now let's have a look at the quantitative predictors, and we start with one predictor. And in general, we can have this form of equation for our model, but remember that x1 in here does not necessarily just represent a straight line model, but it can take any form of functional form of functions, depends on what is the real or the actual relationship between our predictor x and the response variable y. And in order to be able to do that, it's really recommended that we do our visualization. So we have our predictor here, we have our response variable here on the y-axis, and then you do some plots of your data. So for example, if you plot your data and you get, like for example, this kind of pattern, then it clearly shows us that it is a curvature instead of a straight line model. And in that case, probably we need to consider this kind of model that is a polynomial, and because it's a curvature, so we need a polynomial of a second order. So instead of having something like this, the one that we need to put in the model should be beta naught plus beta 1x plus beta 2x squared, something like that. Other kind of transformations also can be chosen. Depends of what the pattern that is given to you by the plotting the data. So you can choose, for example, an inverse function. You can choose a logarithm function. You can choose a square root function or any other functions based on, again, the pattern that's given by visualization. That's what we can do for one predictor of quantitative data. Now, if we have two predictors or more, in addition to determining the correct appropriate functional form of each of predictors, we also need to consider whether we only need to include just a first order model. In here, this is the first order model. If it only has two predictors, and it is also called the main effect model, whether we need to consider only the main effect model, or we need to consider, for example, like, is there any interactions between the variables, the predictor variables? For example, in here, do we need to consider the interaction between x1 and x2? So instead of having just the main effect, we also need to include, for example, beta 3, x1, and x2. Okay, there's a way to check whether there is an interaction between the predictors or not, and we will discuss it in a more detail in another video. Also, whether we should consider, including the second order model, like the quadratic here, probably do we need to include like plus x1 squared? Okay, this is beta 4, and do we need to include like beta 5 x2 squared, something like that. And even we also need to consider whether we need to include even higher order model. Okay, to be able to determine the kind of transformation or order of the model, there should be some procedures that we need to do, and it will be discussed in detail in another video. Now we move on to the qualitative predictors. Again, if there is one predictor, the concern is that, okay, how many dummy variables I need to create if I have only two levels for this variable? What if it has 3 or more levels? And in creating the dummy variable, we always have to set one category as the baseline or as the reference. So the problem is that that we need to think of is that which category or which level that should I set to be the baseline, or what if I change the baseline? What is the effect of changing the baseline to the estimated value of the regression coefficient? Those are the things that probably that should be elaborate more in having qualitative predictors in our model. And then we move on. If we have two predictors or more, the same issues, similar issues like what we have in the quantitative predictors, that is whether we need only to include the first order model. We also need to consider whether there is an interaction between the predictors here, and then in the case when there is an interaction, how can we incorporate those interactions for qualitative predictors, because it's slightly different with the quantitative predictors due to we have to define dummy variables to represent those qualitative predictors. And is there any issue or is there any concern about having higher order model for qualitative predictors, for example, does it make sense if I have a quadratic form in our model? That also should be thought of when we do modeling with the qualitative predictors. And now if we have quantitative and qualitative predictors, a mixture of those two types of predictors in our model, again, the concern is that, okay, is it just the main effect? Is there an interaction? If there are interactions, like we know how to do the interaction between quantitative predictors, and then later on we know how to do interaction between qualitative predictors, but now how to accommodate the interaction between quantitative and qualitative predictors, just in case those interactions should be included in the model. There is also a procedure to determine that kind of actions. And also, again, the same whether we should include second order model or even higher order model in the, even higher order terms in our model. So, sum up this video, we can say that model building is a process, is really important, an important process to determine the inclusion of a set of predictors in a model with the proper functional form. So this is the focus of model building, the proper functional forms in order to fit the data properly. And different types of data might require different treatment in model building.